Hello everybody. Today on Bonding for Borons, we will be talking about metallic bonding. Right here we have some different pieces of metals, but the real question is, what bonds would these metals have? What bond allows these pieces of metal to have different shapes and sizes?
It's a metallic bond, which involves all metals bonding to metals. It is very different from a covalent and ionic bond. Instead of a bond between two atoms, such as a metal and nonmetal, the metallic bond is the sharing of electrons between many atoms of a metal element. A metallic bond is also an intermolecular force, and its purpose is to achieve a low energy state. The balls represent metal atoms, and the water you add fills the spaces in between and represents the valence electrons. The valence electrons float around in the sea of electrons. The metal atoms become positive ions. This results in positive metal atoms that are surrounded by a sea of negative electrons that hold the ions together like glue.
Notice that even when the metal is being hammered, all that is changing is its shape. Nothing is being gained or lost. The protons may be rearranged, but the sea of electrons will adjust to the new formation. Another example is unfolding a paperclip. It's still the same, just in a different shape. This is why metals are malleable and ductile.
Like Leah has said, nothing in the sheet metal was really changing other than the shape. Relating this to our sea of electrons, I can pour this into this cup, and there's still the same amount of marbles, metal atoms, and water, valence electrons, as there were in the original container. As we all know, or should know, metals do conduct electricity a lot better. Leah here can stick the plastic spoon into the socket without getting shocked. But what happens when you stick a metal knife into the socket?
In the sea of electrons, there are free valence electrons that are free to flow through a metal, therefore carrying a current. Insulating materials, like a plastic spoon, do not contain free-moving electrons, so they are unable to carry a current.
So to demonstrate how metals are better heat conductors, we boiled a kettle of water and poured it into a bowl and added some butter to the top of a plastic spoon and a metal spoon. We also added a gummy onto the butter so it would be easier to see which melts first. Metals conduct heat so well for two reasons. One, they have free-moving electrons that allow the heat to move through the metal like a current. And two, the free-moving electrons in metals move chaotically when they are heated as more energy is added and they vibrate a lot faster, unlike glass and plastic, whose electrons have little freedom to move around.
One, two, three, action! Turn!
And we're back! What's happening?
Okay, never mind. Restart.
No, I thought she was gonna count for us! So after we hit the tune...
Metallic bonds.
See you later, folks.